Welcome to Projects from the Bottom Drawer. My name is Brian, and you can find us at wearboard.com/projects or bottomdrawerprojects.com. On the bench today, I have this oscilloscope. This is one of RCA's scopes. It says RCA Institutes. I assume this was part of a training course. It was picked up at Dayton 2026 a few days ago. Wasn't that much. It's dirty, but intact. Still has the previous owner's name on it, which I will cover up, but I assume that that gentleman is a silent key, which is why I have the scope now. I haven't tried this guy out. I don't see anything on the outside to indicate that it was a rain discount item, because it did rain quite a bit there Saturday. So let's start by, always check the fuse. If the fuse is blown, you know there are probably some issues, and I can't really see the wire in this one, so let's get a meter out and test this guy. And this should work. We just need some quick cables here. Let's see, let's put you in BP mode. No, auto range. I want this button, the one right above it. Works much better when you press the correct button. All right. So fuse, one end. Fuse is blown. I wonder why. So what is this? This is a 1 amp 3AG. I wonder if I've even got any of those in stock. And if I do, where in this mess would those be? Stand by, and I shall look for a fuse. Here we go. Pack of 3AG 1 amp Seneca fuses. Seneca, of course, used to be a Columbus, Ohio company. They were bought out and moved, and I lost track of the owners of the company that bought them. They seem to be completely gone. So let's get, come on. Oh, these little packets were almost impossible to open. This one is not cooperating with me. There we go. Let's slide that out. So I'm going to put this in and test across the line to see what happens. I'm not going to dim bulb it or anything. Just going to see what the reading across the line is, see if we've got a shorted input transformer or something. Okay, back to resistance. All right. Let's see, let's move you over here so everybody can see the meter. Let's do 67 ohms. That's probably a good input transformer. But before we do that, let's just open this guy up and see what's inside. That's an interesting screw. I guess I didn't need to cover the guy's name up, since you can see it there. Oh well. Let's push this out. Oh wow. Bits and pieces of tape and paper falling out. So, what do we have inside? Let's see. First of all, the CRT shield has come off, and that might be why we have a short, or why the thing's shorted. Because if that nice piece of shiny foil was laying on some of these exposed terminals, especially like down here, yeah, that could definitely short the system out. So on the back, it states that this is a model 54-45, built by John L. Let's see, Kinnican. So yes, this was probably part of a radio kit of some sort. Everything is labeled. He's labeled the tubes. There are pots up here in the main area that are labeled. Let's see. Everything is very well laid out. I mean, you can see that there's labels everywhere. We've got the rectifier. Here's one of the compactrons. This is probably a sweep tube. Here's an amplifier. Let's see what we got. I see Dymo tape everywhere. That's kind of cool. Some high voltage capacitors. I mean, this thing is fairly well built. I mean, this guy knew what he was doing. And that's definitely a pleasure based on some of these kits that I've had come across the bench that I've had to restore. So there's nothing really unusual in this scope as far as the tube lineup. I mean, you've got your amplifiers, your sweeps. This compactron, this 6D10, I believe that's 3 triodes. Don't quote me on that. I would have to look that up. And then I see a 1V2 back there for the high voltage rectifier. So this probably went like this. And we'll have to retape that. And while this device will run fine without this shield, the signal on the face of the CRT can get very noisy. It's just a way to insulate the deflection plates from the rest of the device. And a piece of tape, there's nothing on there. Let's see, do I have any electrical tape handy? And we've got this orange stuff I bought at Dayton 2020, no, when 2025, was that 2014? So let's see, let's put the shield back on before we do anything. Let's see, let's cut this. We'll just get this started and then we'll wrap it well. And I'm hoping that's the reason the fuse is blown. Just that shield was laying on something live. And this shield actually does not look original. This looks like something that the builder would have put in here. And it's very possible, you know, he may have done that to solve problems. There's some nice electrical tape. All right, let's wrap you around. Yeah, looks like crap, but it'll do. I'll probably take that off later and redo that. I don't like the way that looks, but this is just for testing purposes. Let's see. All right. So, and I will admit, I did turn this on briefly last night. No trace. But I didn't check the fuse, and obviously the fuse is bad. So let's give it a try. We have that big floppy piece of metal out of the way. Let's see. Let's turn it off. Let me bring my power switch down here. That's weird electrical tape. I don't know where that came from. No, I think the fuse just blew. Yeah, nothing's lighting up. And I saw a little flash down there at the bottom. So I think that fuse just blew again. It sure did. That is pop, pop. So there's a problem somewhere else. And that's not the... And it's not necessarily the inputs or that shield. So what all... So let's see, we've got... It runs up to the switch. Let's see, into the transformer. Well, there's not a whole lot in here to cause that, to be honest. Because this... Yeah, it comes in here, runs over to here, runs up to the switch and back, and then straight into the transformer. Interesting. I wonder what could be... that's an interesting candidate. So I wonder what could be a dead short here. I wonder if this... Let's check the capacitors, I guess. while we're in here. Let's see. Oh, that's tight. Wow, that doesn't want to move. There we go. Let's see, can we get this out of the way? Kind of. So let's see. How is that in there? Where's the ground? Is that case ground and he just didn't solder it? How many is in here? 1, 2, 3, 4. Can is common. Okay, so he didn't really ground it with a solder joint. Okay, well maybe he didn't necessarily do everything by the book, but hey, whatever. So let's discharge those capacitors. Let's see, we'll get a good ground here. Make sure there's nothing in them. All right, let's get the capacitance meter out. Let's see. (120 hertz). Let's see. That's a scope probe. I just had probes here. Here we go. And I'm not going to use the Kelvin clips for this one. It's not necessary. I mean, those are cool, but for what we're doing here, it's just not necessary. All right, let's see. Where can I get the best ground here? Let's just try and pick it right up off the capacitor can. 28 microfarads, 26 at 2.8 ohms, 25 at 3, 44 at 2, and 24 at 3. So let's see, it should be a 40, 20, 20, and 20. So that capacitor's good. So that's not shorted. So we checked across the line, but if the fuse was bad, that doesn't mean anything. So let's go back to the ohm meter. See what we got here. So obviously I'm not going to put another fuse in and blow it. Check to... Okay, nothing from that terminal to ground. Nothing from that terminal to ground. Nothing from that terminal to ground. Are we on? Yeah, no. Nothing from that terminal. That terminal. That terminal. That terminal. So something in here obviously is drawing a lot of current. And let's just give it a good once over. You always want to look it over well before really getting into something. Let's see. These little TO capacitors are Very suspect. I've seen those shorted in the past. So let's just do a quick check on those. Take frequency up to 1 kilohertz. Let's see, here's one. Uh, 0.1. And these really shouldn't. 101. Now that one is way different than the other two. What's the reactance on that? All right, well that looks fine. I mean, I've seen those that they were just a dead short. So even in circuit, I mean, so the fact that they're actually reading something in circuit tells me that they're good. Let's see, here's one of the high voltage filters, okay. A couple of big honking capacitors up here, let's see. All right. All right. All right. All right. Let's see, any resistors that look bad? I don't see anything that looks burnt or otherwise destroyed. There's a little 10 mics in there. Let's see what you're up to here, Mr. Microfarads. Let's see. R. Kind of tired, but yeah, it's okay. Let's see, what else do we have in here that might be suspicious that we can check real quick? Let's see. This is a weird 0.1 over here on this side. Yeah, that's fine. So anything else up here? There's another one of these teal capacitors buried back in here. Let's see what you're doing up to. Yeah, that one's fine, 0.22. R12. Let's see, what do you get if I short you out? Overload. Okay, so that switch is good. So let's just... Okay, no, you're good. let's see. How about you? Are you good? Yeah, you've still got continuity on your filament. So interesting. This device definitely has some issues. And I don't necessarily see anything that could cause that right offhand. I was hoping the shield laying on the chassis would be the problem, but obviously that is not the problem. Let's see, just one more quick look here. Definitely some rust. A little bit of basement muck there up front. Sorry about that. Let's see, yeah, this one's another one. It's just going to have the schematic pulled. At least I know the model number now, which I didn't before because it's not on there, so I can probably find the schematic fairly easily. Is it worth fixing? I only gave a few bucks for it. It's an interesting piece. Let's see. Yeah, the cord's got some burns in it, but there's nothing there that would cause that. So, yeah, like I said, it's going to have the schematic before I can really do anything with it. I'll probably pull the tubes and just give them a quick emissions test to make sure nothing's shorted there. And then maybe just disconnect the part of the transformer. Speaking of the transformer, yes, we can check that. That looks like, let's see, we've got multiple sections here. Can I even get into these? Oh boy, there is red. Okay, that looks like the, here looks like the high voltage secondary right in there. Let's just check those real quick to ground. Put the capacitor meter away. Throw our newly blown fuse away, because obviously we don't want burnt fuses. We'll, let's see. All right, let's just go to ground here and see what the secondary reads to ground. 208 ohms, that's fine. $230 ohms, that's fine. Here's the center tap. Yeah, that's fine. Let's see. Just pick up one of the filament lines for the tubes. Let's see, that's probably, yeah, it looks like he used yellow. So that is these guys right here. Okay, let's go 22 ohms to ground. 1 ohms to ground. I mean, I wouldn't think you'd have ground there, so let's, unless one side's grounded somewhere, which it very well could be. So let's just pull out all the tubes gently. 6BL8. 12AU7. Let's see, 6D10. Man, these sockets are nice and tight. Not like that crap that Heathkit used in the other device we just had on the bench today. Let's pull the socket off the CRT again. So the filaments should be completely isolated now. So let's do this again. Let's get ground over here. All right, you're good. Okay, so this side must be connected to ground somewhere. Let's see. Now, is it supposed to be? Who knows? Let's see. Brown. Yeah, I'm going to have to get the schematic for this. This is just... This crap's just flying everywhere. Brown and green. Let's see, yellow, yellow, yellow. Yellow runs all the way here up to where? Yeah, he's got it marked as 6.3 on the back of the unit. So let's check there real quick. What do we got across the 6.3 lines? .3 ohms. That actually seems a little low, but well, let's try this one. This is a got another little transformer here. Let me strip the leads off it real quick. We'll just check across its filaments. It's a lot smaller transformer, but still. .3 ohms. There's a lot more current, so who knows? I'll have to get the schematic out and see what she says. All right, well, thank you for joining me. You can find this and many other devices that I've worked with on wearboard.com/projects.